Hi everybody. We're going to continue with our work on scientific notation. If you, for whatever reason, have forgotten scientific notation, I am going to put the link to my YouTube channel that's got the videos from yesterday somewhere on your page so that you can go in and look at it if you need to. Hopefully that'll help you, but I hope you get on today and move forward and work through some of these negatives. Really putting my trust that you're going to do that so that we don't get caught up, okay? All right, so real quick review. Yesterday we worked on scientific notation. Particularly, we worked on scientific notation. Sorry about the glare, it's hard to see that. We worked on scientific notation if you had just a whole number with a power of 10 that has a positive exponent, or with a decimal with a power of 10 that has a positive exponent. And I'm going to put one more on here so we can look at it. Okay, big things I want you to remember from yesterday and grab. The exponent is not going to tell me how many zeros are in my answer. It tells me how many spaces my decimal moves in my answer. All the exponent does is tells me how many zeros are in my power of 10. So 10 to the 4th would be 10,000 because there's 4 zeros in 10,000. 10 to the 5th would be 100,000, right? The zeros in the 10 are what pushes my decimal point over and makes my number bigger, right? So 7 times 10 to the 3rd would be 7,000, okay? So in that case, the number of zeros matches with the exponent. But if we look down at this second example, this is 10 to the 5th. My decimal point started between my 3 and my 2. So if I start here, there's 1, 2, 3, 4, 5. And then I have to move my decimal out from in between the 3 and the 2 and put it at the end. And anything that doesn't have a number, I put a 0. So in this case, the exponent's 5, but there's only 3 zeros, right? Because this exponent tells me how many numbers are going to be behind that first number. Right? So then this one's going to look a little weird because when we actually put this in standard, there's not going to be any zeros, okay? The exponent is 4, so I'm going to rewrite my coefficient. If this is where my decimal started, between the 2 and the 1, there's 1, 2, 3, 4 places. So I'm going to move my decimal point out from between the 2 and the 1 and put it on the end. There are no zeros in the standard form, but there are 4 numbers behind that first one because I moved my decimal place 4. Now, the other thing I'm just going to real quick reiterate, you'll notice that the decimal points are at the end of each of these numbers. These are whole numbers. These are not decimals. We moved them from between the first 2 to the end. Move them from where they start to the end. Now, something I noticed yesterday that we struggled with was where to put commas in numbers like this. Start from the right side. And it's every third one. So count 3 left, put a comma. So 1, 2, 3, comma. For this one, you'd start at the decimal, 1, 2, 3, comma. And then this one, start here, 1, 2, 3, comma. And you just do that until there are no more groups of 3s. And that's how you have it. So this is an example of what we did yesterday. Okay? Today, we're going to move on. We're going to talk about what happens when you have a negative exponent. And I'm not going to get as in-depth into the powers of 10 like I did yesterday until the end. We're going to talk about it a little bit. But we said yesterday scientific notation is writing very large numbers and very small numbers. So a very small number would look like something like this. It's a lot of zeros, it's a lot of writing, but this is a tiny number. If this was this in inches, it would be like half of a sliver of a piece of paper, right? Really thin, small number. It's not negative. It's between 0 and 1, but it's tiny. Like on a number line, if I have 0 and 1, this number would be like all the way over here, like almost 0, but not quite 0. If I rounded it, it's basically nothing, okay? Still positive, just really small. So we can use scientific notation to write these numbers too. Same thing. You want to figure out what your significant digits are. And then all the numbers that aren't 0. So in this case, it's 9 and 7, right? So I'm going to start. That's going to be my coefficient, 9.7. And I know it's going to be a power of 10 because all scientific notation has a coefficient and a power of 10. Now, it's still the same, right? Your 9 point, it has to be between 1 and 10, so it has to go between these two numbers. So this is where it starts. You need to figure out how many spaces it has to go to get here, where it started originally. So in this case, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 places. 13 places. So from the 9 all the way over, there are 13 spaces. So it's 13, but because this is a tiny, tiny, tiny number, it's a negative 13. So find your significant digits. Your decimal has to make those significant digits between 1 and 10. What do I mean by that? Had I put the decimal point over here, it would have been 0.97. That's less than 1. If I put it on this way, it would have been 97. That's way more than 10. So it's got to go between these to make it 9.7. Okay? Let's go the other way. Let's say I give you 8.4 times 10 to the negative 6th. Okay? 8.4 times 10 to the negative 6th. Now, powers of 10 with negatives are the same, right? In fact, what you need to know about negatives, what you'll learn is that the reason that the negatives make these tiny, tiny decimals is because a negative exponent really just makes this a fraction. So 10 to the negative 6th would be the same thing as 1 over 10 to the 6th. So it really just means you're dividing by 10 to the 6th. We don't have to get into that right now, but that's why it makes this tiny decimal. So with this scientific notation, what you're actually doing is you're doing 8.4 times this, which is 8.4 times 1 over a million. Okay, so that's why it makes this tiny, tiny little decimal here. Now, you could do this every time. You could figure out, you could pull out, just like we did yesterday, the power of 10, right? So you're pulling out the 1 over 1 million, and you're multiplying it by 8.4. But don't get caught up in that number sense if it's going to confuse you. Just remember, start with your coefficient. So I'm going to rewrite my coefficient. And my decimal place is between the 8 and the 4. It's a negative 6, so I know I'm going to move it 6 places, and because it's negative, I'm going to go to the left. So 1, 2, 3, 4, 5, 6. I'm taking it out from between the 8 and the 4, and I'm putting it over here, and everything else is going to just get a 0 to fill in. Okay? So I'm going to rewrite this just to make it nicer. 0.1, 2, 3, 4, 8, 4. Now, the last thing that you're going to see is what we call a leading 0. Once you've done this, once you've moved the decimal point, you just add this leading 0 so that you know it's 0 point something. This 0 has absolutely nothing to do with the exponent. Nothing. You just add it at the end. Okay? I'm going to show you 1 or 2 more. I'm going to show you 2 more probably, and then I'm going to have you guys start working. So let's look at 0. No, oops, my bad. Scratch that. Let's do 1.3 times 10 to the negative second, and let's do 5.321 times 10 to the negative third. Okay? So 1.3 times 10 to the negative second. 1.3, it's negative 2, so I'm going to move it to the left 2 places. Take my decimal point out, put it in the new spot, and then I'm going to add my 0, and then the placeholder. That's my number, add my leading 0. And then ask yourself, negative 2 is my exponent. That means that between where my decimal started and where it ends, there should be 2 places. And there are. So then here, we've got 5.321. Same thing, it's negative 3, which means from here, I'm going to move to the left, 1, 2, 3, put my decimal point, take it out of here, and then add my zeros where the placeholder should go. and then add my leading 0. And then check your work. If it's -3, then it started between the 5 and the 3. There should be 1, 2, 3 numbers between where the decimal place started and where it ended up. And there are. And that's it. Okay? When you're in person, we'll talk a little bit more about those powers of tens and what these negative exponents mean, because I do think it's important that you understand that just for its value for number sense. But for now, if it's negative, move it to the left however many places. If it's positive, move it to the right however many places. And that's all, folks. That's all you got to work on today. Have a great day.